expression for lateral displacement. Here, this is incident ray. If there is no glass, then it would follow this path. But because of presence of glass, there is refraction and the ray bends towards the normal and it follows this path. At this point, the medium ends and it becomes parallel to original path. So this distance CE is called lateral displacement, and now we are going to derive the expression for it. So here this angle is I, this whole angle will be I vertically opposite, but since this angle is R, so this will be I minus R. So thickness of glass is T, that is BF equal to T. And let's find out the relation between BF and BC. So BF is base divided by BC is hypotenuse equal to cos, and this angle is R. So BF equal to T. So T divided by BC equal to cos R, from where we get BC equal to T upon cos R. Now we consider the triangle BCE, perpendicular upon hypotenuse sine theta. So in a triangle BCE, perpendicular is x, which is to be found, divided by hypotenuse is BC equal to angle is sine I minus R. But BC equal to T cos R, so we get x equal to T upon cos R times sine I minus R, and we can expand this sine I minus R. So T upon cos R times sine I cos R minus cos I sine R. So for the right, x equal to, we take cos R inside, so T times sine I minus cos I sine R divided by cos R. Now we know that mu equal to sine I divided by sine R. So sine R will be equal to sine I divided by mu, and cos R equal to root of 1 minus sine square R, that is 1 minus sine square I divided by mu square, from where we get 1 upon mu root of mu square minus sine square I. So we put this value here, x equal to T times sine I minus cos I times sine R equal to sine I upon mu times cos R equal to 1 upon mu times root of mu square minus sine square I. Sine I can be taken common, so T times sine I 1 minus cos I divided by this mu will cancel out. So cos I divided by root of mu square minus sine square I, which are final expression. Now, if we want to specify, so we can say from this expression, x equal to T sine I 1 minus cos I divided by root of mu square minus sine square I. So x tends to maximum when I equal to 90 degree. So x will be x max when I equal to 90 degree, because in that case this term will become 0, and if this term becomes 0, so here 1 will be left, and here this I is 90 degree, so we can say x equal to t times sine 90. Other terms will become 1 minus cos 90, and root of mu square minus sine square 90. So this will be 0. So we will get x equal to t. Now we can say that the lateral shifts produced by a glass slab increases with the increase in thickness of glass slab. If T will be more, obviously lateral displacement will be more, and if angle of incidence increases, in that case also the lateral displacement will increase, and if refractive index is larger, in that case also the value of x will increase. Now we are going to see one numerical. So question is, a parallel sides glass slab of thickness 6 cm is made up of material of refractive index root 3. When light is incident on one of the parallel faces at an angle of 60 degree, it emerges from the other parallel face. Find the lateral displacement of the emergent beam. Here, situation is shown. This angle is 60 degree, and this is lateral displacement. We have to find out its value, and the thickness of glass slab is given as 6 centimeter. So here again, if we level it as C, so BC will be T upon cos R, as we have found earlier, and also x will be equal to x perpendicular upon hypotenuse, and this angle is I minus R. So x will be equal to T upon cos R times sine I minus R, and from Snell's law we know that mu equal to sine I upon sine R, and we are given the values. So mu is root 3, sine 60, it's given, divided by sine R. So from here we get sine R equal to sine 60 is root 3 by 2, and this will become 1 upon root 3. So this will give 1 by 2. So R equal to 30 degree. So we have got the value of R also. Now we put these values here. So x, which is lateral shift, t is given as 6 centimeter, cos of R is 30 degree, times sine I minus R. I is 60, R is 30, so sine 30. So 6 times sine 30 is 1 upon 2, and cos 30 is root 3 upon 2. So this 2 will cancel out, 6 upon root 3. Now we can rationalize, so 6 into root 3 upon 3, which will become 2 root 3. And if we put the value of root 3, so 2 into 1.732, so this will become 3.564 centimeter. Thank you for watching.